Welcome to Physics Everywhere. In this video, we are going to be looking at determining the Hooke's constant using a spring and a mass. We start off with the vertical spring scale. We have zeroed it. Then we'll take a known mass. In this case, it's 200 grams. Very carefully, we'll take the mass and put it on the pan balance, and then very slowly let it go down. We don't want this to start oscillating, so we're just going to very carefully lower it. Try to keep it from vibrating up and down. We see that the spring has been stretched. And we'll now note the new length of the spring, which is 7 centimeters in length. Okay, so here was the situation. When the spring scale was zeroed, we had our marker at the 0 point. We added the 200 gram mass, and when that was done, the marker went down to 7 centimeters. So we went from 0 to 7. We can say, therefore, the spring was stretched 7 centimeters or 0.0700 meters. So we're going to look at a free body diagram. We have gravity pulling down, 200 gram mass times the force of gravity, 9.8 newtons per meter. If this is in equilibrium, which it was because it was stationary, that eventually means that we'll have to look at the force of gravity being equal to the spring force, which is Fx pointed upwards. So 0.200 kilograms times 9.8 newtons per meter, that gives us 1.96 newtons. So again, the downward force needs to be equal to the upwards force because it was stationary. That means we can say that the spring force upwards is 1.96 newtons. Okay, so the spring force F of x is 1.96 newtons. The equation for forces on a spring is Fx is equal to Kx, and K is the Hooke's constant. So now we can write down that 1.96 newtons is equal to K times the displacement of the spring, which was stretched 7 centimeters or 0.0700 meters. Now we're going to divide both sides by 0.0700 meters. So on the right-hand side, they obviously cancel off. On the left-hand side, we have 1.96 newtons divided by 0.0700 meters. To put that on our calculators, we end up getting 28.0, and we have newtons on the top and meters on the bottom. And the units for the spring constant is newtons per meter. So this basically means that you would need 28 newtons in order to stretch that spring a distance of 1 meter.